We'll proceed in vector and commercial calculus. Vector and commercial calculus, that is the discussion that we are pursuing. Very long discussion, and we are in a phase of calculating the flux. Flux. Flux means if I have a velocity vector, if I have a velocity vector and velocity is passing through a surface, if velocity is passing through a surface, then what is the flux coming out of the surface? So that is the discussion. That is the discussion that we are pursuing. Okay, so okay, so if this is the area and this is the flux, this is the I'm sorry, there is a liquid, there is a liquid and it is flowing like this and it is touching a surface, then how much is the liquid coming out of the surface? If this is the liquid and it is touching the surface, then how much is the liquid coming out of the surface? The velocity of the liquid multiplied by the surface area, multiplied by the surface area. Velocity into surface area is the flux or volume of the liquid that is coming out of the surface. Okay, if velocity is in this direction, if velocity is in this direction and surface area vector is perpendicular to the surface. Either it can be this or it can be this side, any side. Depends upon the orientation of the surface curve. If surface curve is oriented in this fashion, if surface curve is oriented in a kind of this is, if I take from my side like this, then this is oriented like this, then it is anti-clockwise. If it is oriented in anti-clockwise, okay, or if I take left finger, then if this is x, so the surface is pointing toward me. So if it is kept like this, if it is kept like this, the surface is pointing this surface, this side of the surface is, is pointing this side. So if it is going like this, if it is going like this, then this side of the surface is pointing like this. Okay, if it is going like this, if I see from here, then this is clockwise direction. If it is clockwise direction, then it is this way. If I say like this, then this is this way. If I keep like this, then this side surface is, direction is like this, and this side surface direction is like this. Surface area vector is perpendicular to the surface in the direction. So someone can take like thumb rule. If this is the direction, then this is the direction of the surface area vector. Okay, so what we have learned is velocity vector dot product with the surface area vector. Velocity into surface area is the net liquid coming out of the surface. If this is the surface and this is the liquid that is hitting the surface, there is a, I have given example, there is a river. Someone has to calculate the velocity of the water that is flowing in the river. What is the velocity of water that is flowing in the river in some certain section of the river? Every region of the river will not have the same velocity. If someone just enter into the river, then it will be like a still water. But as you go at the center of the river, then velocity of the water will be certainly very high. There, like like take a take a like a hollow kind of circle and take a big bag, some kind of rubber bag that can fold into a plastic bag in a very small, sew it, the side open side of the bag, sew it here, okay, and completely close it and go to the a river where velocity is very high, then insert it inside the river. Make sure the fluid direction, if this is the fluid direction, then this surface has direction like this. They match the direction. Exactly the angle between the fluid direction and river direction, this angle is zero. If this angle is zero, if this angle is zero, then unfold it, the bag. Count, make the counter and see 60 seconds, something like that. See how much water is filled. Just take it out. See what is the volume of the water that is stored in the bag. See what is the area. Volume by area is the net velocity of the of water at that moment. Otherwise, it is very difficult to calculate the velocity of the water. Other fashion. So velocity of the liquid multiplied by the area is the net volume of the liquid that is coming out of the area, or velocity vector dot product with the area vector is the net flux. If velocity is exactly perpendicular to the area vector, then nothing is coming out of here. Something, the bag example I have given, if this is a river flowing like this, go and open bag like this, just keep like this and open the bag. Nothing will, no water will enter into the bag, because the river velocity is this direction and the surface area velocity area vector is, they're 90 degree to each other. So velocity vector dot surface area vector is the net volume of the liquid that is coming out of the surface. Okay, if that is the case, then V dot area vector. Area vector is same as D of position vector. Hope. I have given many times this example. Consider, consider, or or in simple fashion, you consider this is the area. This is the area. Okay, this full is the area. Consider somewhere here is the origin of the coordinate. This is x-axis, this is y-axis, this is z-axis. In that sense, if I take any point on this area as P, then if I connect a line to the P, this is called P vector on the surface. On the surface, take any point here called P, and from the origin connect this point, then this will become a position vector. This will become a position vector. Velocity vector dot area vector is the net flux. If velocity vector is algebraic vector, where dependency of the orthogonal component x-axis, y-axis, z-axis is seen, then it is velocity vector dot d of position vector. P is a point on the surface. Or if I have a surface like this, if I have a surface like this, if I have a surface like this ball is a sphere and it is centered at the origin. The center of this ball is the origin. X-axis, y-axis, z-axis. This ball center is the origin. Now, if this ball center is the origin, then I'll take any point P here. From the origin, draw a line like this. That is the position vector. Velocity vector dot d of position vector is the net flux. Now I have given example, there is an electric charge. It is kept at the center, small charge kept at the center. The flux, the velocity, electric field. If there is electric charge all around it, electric field is generating and it is flowing. Like a radio tower. If anyone who has seen the radio tower, there is an antenna on top of it, and then electromagnetic wave is generated from here and it is flowing. But it will be unidirectional. It will flow in one direction. I believe radio will flow direction will be omnidirectional. This is what I believe so. Or if it is not up, not down, but in XY plane, it will be omnidirectional. But if I place a Q charge in full plane X, Y, Z, three dimension, it will be omnidirectional. The equation is QR vector divided by R to the power 3, where R is the direction and distance from the charge. If this is the charge, then this is the R distance, all direction, this is the R distance. This is a spherical coordinate system. So consider the electromagnetic field as a liquid, some liquid, and it is emanating from the electric charge. If it is crossing this surface, then how much is the net volume of the electrical magnetic field that is coming out per second from this surface? We have calculated it. If the if electric liquid is flowing outside and formula is Q, that is the electric charge, Q into R vector divided by R to the power 3. R vector means, if take a spherical coordinate system, then all around it is R vector. This is R vector, this is R vector, this is R vector. Means from the center, whatever is radial. Whereas if I take Cartesian coordinate system, this is x-axis that will go like this in one direction only. y-axis, z-axis. Where in a spherical coordinate system, if this is center, then these all are r vector. All. Okay. What about q and phi? They are another orthogonal component in a spherical coordinate system. Q is this angle in xy plane, it rotating like this, 0 to 2 pi. The q vector is, if I take the circle, if I take the arc q, if this is radius and it is rotating like this, it is making an arc. This arc tangent at any moment, this arc, this is the arc. This is the arc around this center. This is the arc. And radius is rotating like this, 2 pi. This is the theta. This is the theta vector. Okay, similarly, phi vector is a, if radius moves in a perpendicular plane can be xz plane, yz plane, or any xyz plane, perpendicular plane, whatever it is making the kind of curve, that tangent, one is horizontal tangent, that is theta degree vector, one is vertical tangent, that is the phi vector. Three are, this tangent means this line, this curve, horizontal curve and radius, everywhere, you take anywhere, all three are at 90 degree. This is how spherical coordinate system is. Now question is arising, we had given one assignment in the past video. Okay, one thing is that if there is an electric charge kept at the center of this sphere and power of the electric charge is q into r vector divided by r to the power 3, whereas this sphere has radius of r, same r, then how much is the electric flux coming out of the surface? Then velocity vector d of position vector, velocity vector d of position vector. Velocity vector is qr vector divided by r to the power 3, dot product d of position vector. D of any point P here from center, if you connect a line, that is the position vector. D of position vector is same as d of P by dxy plane into dxy plane, or d of P by d theta phi. If we are talking about the surface, then radius is constant. Theta and phi are varying. That's why it is forming a surface in a spherical coordinate system. In that sense, dp by d theta r plane into d theta. It's clear, right? If there is a charge, electric charge kept at the center of this sphere, then electric radiation or electric field is emanating from it and going in all directions. And its equation is q, that is the charge r vector divided by r to the power 3. When it is coming out of this sphere surface, when it is coming out of this sphere surface, how much is coming out of this sphere surface where the radius is r? Velocity vector, that is qr vector divided by r to the power 3, dot product of area vector. Area vector, to calculate the area vector, that is d of area position vector, that is p. At any point, if I take point P and from the center if I take a vector, that is position vector. Whereas area vector, if I take any portion here, small portion here, then area vector is exactly perpendicular to the area. If it is a sphere, then position vector and area vector are in same direction, but it is not the case for every kind of shape. Okay, if shape is different, then position vector will be like this and area vector will be not required. Okay, but for circle sphere, generally it is seen that the position vector and area vector, they are in same direction. Okay, so that is the scenario. Now we are calculating the velocity vector dot area vector, or velocity vector dot d of position vector. D of position vector gives the area vector. D of position vector is same as d position vector by d theta phi plane into d theta phi plane. D of position vector by d theta phi plane is same as dp by d theta cross dp by d phi. Okay, and d theta phi. Okay, if I take in pure spherical coordinate system, then position vector has theta component, r component, and phi component. Theta component is, if I take any radius, if this is the sphere at the center, if I take any radius here and from vertical it is making phi angle, then radius sine phi will fall on xy plane. Cos theta is x, sine theta is y, whatever it is. We are interested in this arc. This arc, this arc is making a theta vector. So if this is r sine phi theta is this arc. Whereas r, if this is angle is phi, if this angle is phi, then r phi is this arc. Vertical arc is r phi, and horizontal arc is r sine phi theta. So the p vector is r sine phi theta vector plus r vector plus r phi vector by d theta cross dp by d phi d theta phi plane. If that is the case, it becomes r cos r sine phi theta unit vector. Other gone, and that side it become by d phi. So r, it become r cos phi theta vector, r cos phi theta vector, and then r phi unit vector. If you do cross product, theta will only here there is only theta unit vector, and that side we have theta vector and phi unit vector. Differentiation of theta vector with d theta will result in theta unit vector. Differentiation of phi vector means phi magnitude and phi unit vector. If you multiply, it becomes phi vector. D phi vector by d phi is phi unit vector. So position vector is r sine phi theta vector plus r vector plus r phi vector in pure spherical coordinate system. So dp is dp by d theta phi plane into d theta phi plane. dp by d theta phi is dp by d theta cross dp by d phi. dp by d theta is r dp by r sine phi theta unit, other gone, and that side dp by d phi is r cos phi theta vector. Next r is gone, and next is r phi unit vector. If you do cross product, only theta will go and match the phi. It will result in r unit vector. So it will become r sine phi, r sine phi, r unit vector. I'm sorry, r square sine phi, r unit vector. And this side, so now the kind of the flux that is coming out is velocity vector q r vector, not r unit vector, r vector divided by r to the power 3 dot product with r square r unit vector d theta d phi. This r vector can be written as r unit vector, that will become r and divided by r to the power 3 1 by r square q into r unit vector divided by r square dot product with sine r square sine phi r unit vector dot product gone, r square gone, q q q d theta d phi. This is what I believe. Oh, sorry. Q sine phi d theta. Sine phi integration is minus cos phi. Phi is from 0 to pi in spherical coordination. That result in 2. 2 into 2 pi d theta integration is theta 4 pi. 4 pi 4 pi is the net 4 pi q is the net flux that is coming out. We'll discuss more on it. Anyone can see now the flux that is coming out of it is independent of any of the component in a spherical coordinate system. It does not have r, it does not have theta, it does not have phi. It is 4 pi q. What is the magnitude of the q into 4 pi? The flux that is coming out of the surface is independent of radius. That is a very big thing. If I take a charge, electric charge, and make a big sphere, very big sphere around it, and see how much is the liquid that is coming out of the sphere. If area is very big, like if velocity, if river is flowing, and if I trying to find out how much is the water coming out of the surface, if this surface, if I take very big, then net volume that will come out will be very high, velocity into area. But if I am taking a charge and I'm trying to see the kind of if The sphere is, if I take very big sphere, then the charge that is coming out, the volume of the electrical charge is coming out of the surface is same as if I take a small sphere. How come it is like that? It should be bigger, right? Because the electric field, if you make bigger sphere, then a sphere surface from the charge, if I take electric charge, the sphere surface from the charge is at high distance. By reaching there, the electric field is becoming less and less prominent if you go far from it. So there, the distance will be more. So the net surface area calculation will be same. If you take a small sphere, if there is electric charge, if I take a small sphere around it, then at this surface, the charge, the electric field power will be high. Power is high into area, it will result into flux that is coming out of it. If I take a big sphere, then reaching their electric field, the strength is less. Multiplied by the higher area will give the same result. This is how it is. So you take any big sphere, if charge is q r vector divided by r to the power 3, then the electric flux, the net velocity, the fluid that is coming out of it is same. Because when it reaches there, it's not a river that everywhere water strength is same. When it is reaching there, the electric field strength is less. Anyway, we had given one questionnaire that considered there is electric field. Okay, this is a multi-trillion dollar question. There is an electric field, there is an electric charge, and it has electric field as q r vector divided by r to the power 3. Consider there is an electric charge that is kept at this base. This is a cylinder. This is a cylinder and its base is closed. Base is kept on the x-axis. Base is kept on the x-axis. Okay, if that is the case, the base is kept on the x-axis. Now, at the center of this circle, there is a circle it forms. If you see what clearly, there is a circle like this. In the center of the circle, here, I place a small charge, electric charge, and all around it, it is emanating electric field. The equation of electric field is q r vector divided by r to the power 3. Now, if it is like this, then it is now the electric charge, the electric field is flowing like this in xy plane. Then it is all around it is flowing. So it is coming out of these surfaces also. It is coming out of. If cylinder is of height z and radius r, small r, cylinder is at height z, cylinder is of height z and radius is small r, and there is a charge kept here, then it is emanating the electric field all around. How much is the flux? How much is the volume of the electric field that is coming out of this surface? This is a multi-trillion dollar question because this solution is not available anywhere else. I believe this question is not available anywhere else. What is the electric field? That is q into q r vector divided by r to the power 3 dot product with the surface area. That will give surface area has a vector only in xy plane. Since cylinder side is vertical. Since cylinder side is vertical, the surface area vector is like this. If it is a sphere, then surface area vector is all around. But for cylinder, surface area vector is like this only. It is in xy plane. Now, velocity vector dot product with the surface area vector. Okay, or velocity vector dot product of dp, d of position vector. Okay, that is the scenario. Now, d of position vector is same as dp by d theta because here, if I see the surface, then this radius is constant all along the surface. Theta angle is varying and z is varying. So that will constitute in the area. So dp, d of position vector is same as dp by d theta z into d theta z. dp by d theta cross dp by dz. Okay, now the position vector of cylinder is r cos theta. I am taking hybrid model, not pure cylindrical coordinate system. Hybrid model. Someone can try in pure cylindrical coordinate system. So it will be r is the radius, r cos theta I plus r sin theta j, that is dp, plus zk by d theta, that will become r minus sin theta I plus r cos theta j plus nothing. Cross product dp by dz, that will become k vector only. Now, if someone settle it down this cross product, then it will become r cos theta I. First is r sin minus r sin theta I and k cross will become minus j, minus minus plus r sin theta j. So it will become r cos theta I plus r sin theta j d theta dz. This is what it is. This is the area vector. The dp, d of p becomes r cos theta I plus r sin theta j d theta dz. Okay, this is the net area vector. Dot product with the velocity vector q, r vector divided by r to the power 3. This r and this r are not same. The electric charge is q, that is a charge, electric charge, r vector divided by r to the power 3 dot product r cos theta I plus r sin theta j d theta dz. This solution is not available anywhere else. Please don't mind supporting us. +91 is the India country code, 94831 60610 is the telephone number. 94831 60610 is the telephone number. +91 is the India country code. Now consider if there is a charge that is if there is a charge that is kept here, this, and I am taking any point here, any point P here, then from there this will make it will make a spherical radius distance from here. The charge, if this is the point P here, if there is a point P here on the cylindrical surface, if there is a point P here, charge is kept here, it will make a diagonal distance, that is the radius of the charge. Charge will make radius in a sphere fashion. Whereas if I take radius of the cylinder, everywhere along the line, radius is the radius of the base, that is another r. This radius of the cylinder, a spherical, is big R. Say it is a big R. And this radius is a small r. Now equation is q big R vector by big R to the power 3 dot product with a small r, because for cylindrical coordinate system this is the radius only in xy plane. A small r cos theta I plus a small r sin theta j d theta dz. These are different. Okay, now if I take the bigger r vector, how I can make it in a small r? Okay, leave it. Leave the bigger r only. If it is bigger r, let's go in a spherical coordinate system, Cartesian coordinate system hybrid model. In that case, bigger r vector can be written as xi plus yj plus zk, where if this is the point and this is the point P, then this is x, this is y, and this is z. Z is same as the z in cylindrical coordinate system. X and y, this is the x and y, same as what is there x and y, but r are different. Anyway, now xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. If that is the case, x can be written as r, big R sin phi cos theta I plus big R sin phi sin theta j plus big R cos phi k. This is spherical coordinate system divided by r to the power 3, or x square plus y square plus z square to the power 3 by 2 to the power 3 by 2. Anyway, now what is r sin phi cos theta? What is sin phi? Now if this is the big R, consider this is the angle it is making with the vertical. This is the angle. If that is true, then this is the height z, any height z. This is the small r of the cylinder. This is cylinder. The charge is kept here and it is radiating like this. This point is touching the cylinder wall. This is cylinder. This is the height of the cylinder. This is the radius of the cylinder. This is the radius of the charge that is in a spherical coordinate system. If this is from vertical, it is making phi angle, then sine phi is r by hypotenuse. Small r by capital R is the sine phi. Makes sense? If this is the phi angle, then vertical, that is this r by this r is the sine phi. Capital R sine phi is a small r by capital R gone. Small r cos theta I came to small r cos theta I plus a small r sine theta j plus capital R cos phi k. That side there is no k. So k factor gone in dot product at all. Now it is r cos theta I plus x become r cos theta. Now r cos theta I plus r sin theta j dot product, there also it is r small r, a small r cos theta I plus r sin theta j. If you do dot product, then it become r square cos square theta plus r square sin square theta. It will become r square. R square divided by x square plus y square plus z square to the power 3 by 2. X becomes r cos theta. R square x become r cos theta. Y becomes r sin theta. Z is z, same z. Okay, now it becomes z is z, or z is z for time being. Now x square plus y square. X square plus y square is a small r square. Okay, if that is, or x, if I keep a small r cos theta, a small r anyway, so it becomes now that the numerator becomes r square. Numerator becomes r square and denominator becomes r square z square to the power 3 by 2. Okay, r square numerator becomes r square and denominator becomes r square plus z square to the power 3 by 2 d theta dz. Now, someone is encouraged to calculate the integration of this. What is the integration of r square divided by r square plus z square to the power 3 by 2? Okay, I don't know. Okay, someone calculate. If it is r square, if it is 1 by, if it is 1 by, I believe 1 by r square plus z square, then it becomes tan inverse z by r. 1 by r tan inverse z by r. This is what I think so. So what is the integration of r square divided by r square plus z square to the power 3 by 2 dz d theta? If someone knows it, he is most welcome and he can try it. This is the actual flux where z is from 0 to h, whatever we have taken the cylinder, and theta is 2 pi. That much is the flux that is coming out of here. If you see this, then this integrand is r square divided by r square plus z square to the power 3 by 2. To the power 3 by 2. That is the integrand here. And it is inversely proportional, and differential is d theta dz. This is inversely proportional to the z. If you grow in z or grow in small r, all are a small r, that is the radius of a cylinder. This r is constant because I have taken a fixed cylinder. If that is the case, if I have taken a constant fixed cylinder, then this radius, this kind of, what is variable here? Variable is z. If I move, if charge is kept here and if I move in the z up, then net flux coming out will be lesser at those points. Okay, makes sense, right? If z is growing like this, the radius will grow like this. The charge radius will grow like this, and it will come in a parallel, more or less. If it is very high, it will come more or less in the parallel of this. At that moment, if z is infinity, then net integration integrand becomes zero. There is no, because it will come as a parallel to the vertical side of the cylinder. No flux will cross it. If z is zero, then it is r square divided by r square to the power 3 by 2, 1 by r. 1 by r. It becomes 1 by r. Means 1 by r 1 by r, only 1 by r. R is constant. dz d theta, dz 0 to h theta, 2 pi h, 2 pi h divided by r, 2 pi h divided by r. Okay, and then q. That is, if you go more in the r by divided by r, the net flux that will come out will be lesser as per the equation, whatever we are seeing. Someone can interpret it. But if z is not 0, then this is all. This solution is not available anyway. I tried thinking of the divergence. Anyway, I can introduce divergence. So this is someone can try. This is $1 trillion solution to an electric charge that is radiating electric field all around it in a spherical manner. And it is kept at origin on XY plane. At origin, charge is kept. There is a cylinder that is kept at the origin. And then along the wall of the cylinder, how much is the flux that is coming out? If I take of height h, then up to height h, if I take this full wall of the cylinder, how much is the flux that is coming out? Where the electric field that is coming out of the charge is qr vector divided by r to the power 3. That r is in a spherical coordinate system. Whereas area vector of the cylinder is r cos theta I plus r sin theta j d theta dz, where this r is r in the xy plane only, because there is no concept of r in a spherical in cylindrical coordinate system. R is only in the xy plane, not this r. Z, r and theta. Okay, so one is qr vector divided by r to the power 3 and another is small r, cylindrical coordinate r. First is spherical coordinate r, second is cylindrical coordinate r. Then try to find it. And it comes as cylindrical r square by cylindrical r square plus z square to the power 3 by 2 d theta dz. Integration over z is 0 to h and theta is 0 to 2 pi. Outside, okay, q is there. That is the net flux that comes out of it. You can set z any typical value and try calculating the integral also. Anyway, that is the solution. Okay, we will little bit talk about the divergence. There is a word that comes in divergence. Mathematicians, they don't like anything that has a dimension. Okay, what is the flux? Velocity dot product with the area vector. Here area has a dimension, velocity also has a dimension, meter per second. If I say, if I have a surface, if I have a surface, if I have a surface, charge, then the electric charge center at the origin, and there is a surface like this, then from the surface, how much is the flux that is coming out of it? Divide it by the volume of this surface, volume, not the surface area. The net flux divided by the volume, what it is? Flux is meter cube per second. Divided by the volume is meter cube per second, just per second. What is per second? Just per second. What is per second? Just per second. What is per second? Just per second. This is called divergence. Divergence, little bit example I give. Consider that there is a square. I don't have, there is a cube. Consider this is a cube kind of thing. It is not a cube, but consider there is a cube. There is a liquid that is flowing like this. This surface area and this surface area is same. There is a liquid flowing like this, and velocity of the liquid is 10 meter per second. Consider. But the velocity that liquid, when it is coming out of it, it is considered as 10 meter per second. But it is coming out as 12 meter per second. The liquid entered in this region is 10 meter per second. Liquid came out from here is 12 meter per second. Or liquid that entered here at 10 meter per second, liquid came out from here is 8 meter per second. Looks like there is something there. Either there is one liquid generator is kept there that is generating the liquid. That's why the velocity is growing. because throughput will here, if the surface area is 1, then 1 meter cube per second, 10 meter cube per second is the liquid that is entering here, and this is also 1 meter square, then 12 meter cube liquid is coming out. This proves that there is a liquid source inside there, and that is gushing liquid. So liquid is coming, there is a liquid source here, that is gushing liquid, and net liquid that is coming out from here is more. Velocity is becoming more. To same surface area, velocity is more means more throughput is there. Per second, more liquid is coming out. Means someone is mixing liquid inside it. Okay, if this is consider this is centered at the origin, that this is x-axis, this is y-axis, this is z-axis. If this is x-axis and this is minus x-axis, if I take this straight line, at the middle of it there is origin. So at the origin looks like some liquid is getting mixed. This is called divergence. Divergence means the sense. Now at the origin, what is the divergence? Divergence means at the origin. Now see all through it. See in a spherical region. Three in the. If I am the origin and liquid is coming from here and passing from here, liquid is coming from liquid coming from minus z axis and going to z axis, liquid is coming from minus y axis and going to y axis. Three-way liquid can pass through. Okay, or mixture of all this. Okay, hybrid model of all this. Then if I am at center, then I have to see that whatever is liquid that is approaching me, same liquid should go away from me. Then there is no divergence. Divergence means what is the tendency at any point to generate liquid. Okay, if liquid that is coming at a point from all direction, liquid are coming to a point, then from that point in all direction liquid is flowing. Consider like this. Then whatever liquid is coming to the point and whatever liquid is thrown from the point, if they are same, it does not have any divergence. Divergence means it is not behaving as an electric field generator. It is not behaving as a liquid generator. Whatever is coming, same is going out. Consider one example as minus xi plus yj. This is the equation of a liquid. Minus xi plus yj. If it is minus xi, consider this is the origin. If it is minus xi, if I take x-axis, then liquid is flowing toward the origin, minus xi or x minus I. Means if I take x equal to 10, then it is minus 10i. Here the liquid velocity is 10 and toward the origin. If I take minus x-axis, then minus xi. If I take minus x, then minus xi becomes 10i. Then it is going towards it. From both sides, the liquid is flowing toward the center. That's it. If it is consider the liquid direction is minus xi. From both directions, liquid is coming to the center from both directions. If that is the case, then there is a negative divergence. Means it is behaving as a liquid sink. Liquid is coming from x-axis and y-axis toward the origin, and it is disappearing. That point is sinking the liquid. That is minus xi plus yj. Yj means if I see yj, if it is 10j, then at point 10 liquid is flowing like this. If it is minus 10, then it is minus 10j. Or here this is origin, this is 10 in y. Consider this is y-axis, this is x-axis, and this is y-axis. Consider like this. Then at point 10, the equation is yj, 10j. Liquid is flowing like this. Looks like liquid is emanating from here. Okay. Now here this point is minus 10, but equation is yj. It becomes minus 10j. 10 minus j. Liquid is going towards j axis at 10 velocity. Means liquid is going in this direction and liquid is going in this direction. And minus xi plus yj, that is the equation. Means from x-axis liquid is coming like this and liquid is coming like this toward the center. But same liquid is going this side and this side. Means the the origin is distributing it. If liquid is coming toward the origin from x-axis, it is exactly going toward the y-axis in same fashion. Minus xi plus yj, mind it. Then divergence is zero. There is no liquid source kept here. Same liquid is routed to other direction. Divergence. Divergence means at a particular point, what is the capability of that point to produce liquid? Produce liquid. If it is negative, means it is producing liquid in negative way, means it is sinking or producing. Like black hole in the universe, considered as a negative divergence. It is absorbing all the electromagnetic radiation coming towards it. Whereas sun has positive divergence, it is emanating electromagnetic radiation from it. So we will do more in the divergence and we will do more calculation. Okay, please don't mind supporting us. +91 is the India country code. 94831 60610 is the telephone number. 94831 60610 is the telephone number. +91 is the India country code. Take that as an assignment. Calculate the integration of r square by r square plus z square to the power 3 by 2 d theta dz. Anyway, we will see.